Our home, planet Earth. It is the only planet we know of where life doesn't just exist, it flourishes. It's beautiful, intelligent, loving, and wondrous. And it is all made possible by the perfect balance of our atmosphere, one important part of which is our greenhouse effect. Over 200 years ago, Joseph Fourier found himself thinking about the richness of life in our world and wondering how we are so lucky. Considering how far away the Earth is from the Sun, he calculated that our Earth should be a cold, dead rock, but instead it's a lush, beautiful planet. He theorised that gases in our planet's atmosphere act like glass in a greenhouse, allowing light from the sun to enter, then trapping heat as it tries to leave. Within 40 years, scientists had proven Fourier's theory and had identified the gases, the main ones being carbon dioxide, methane, and water vapour. If we didn't have greenhouse gases in our atmosphere, then our planet would be more like Mars, where temperatures plummet to less than 100 degrees below zero. Too much of these gases, however, would make our planet unbearably hot, like Venus, which has 300 times more carbon dioxide than Earth, and where the average temperature is over 400 degrees Celsius. Its temperature is more than double that of Mercury, even though Mercury is closer to the Sun. Our greenhouse gases are what make Earth the Goldilocks planet. Not too hot, not too cold. A miracle planet, unique in our solar system and perhaps even the universe. Human activities are upsetting this balance. Burning fossil fuels like coal, oil and gas for energy, cutting down trees, producing waste and over-intensive farming all increase the greenhouse gases in our atmosphere. It's like making the glass in a greenhouse thicker, trapping more heat and making our planet warmer. Scientists now know that since humans started burning fossil fuels, carbon dioxide in our atmosphere has increased by almost 50%. Across the globe, temperatures have increased by an average of 1 degree Celsius. This warming changes the temperatures we see throughout the whole year. You can see from this graph how often different temperatures occur in a year. In the middle are the average days, the ones that we see most commonly. At the sides are the hotter and colder days that we don't see as often, and at the ends are the extreme temperatures that are rarely seen. This is what the temperatures were like in the 50s to the 80s. Fast forward to the last decade, and the hot days have become more common. Cold days still happen, but they're not as often, while extremely hot days have gone from making up 1 out of every 100 days in a year to 1 in 10. And now there are new hot temperatures appearing at the extreme end that we've never seen before. For the last 150 years, scientists have examined the connection between rising temperatures and increased greenhouse gases. They put forward many other theories for increasing temperatures: the sun, natural cycles, cosmic radiation and more. All were tested, all were disproved. Scientists have also used ice cores to look backwards at temperatures from before we started measuring them, and have revealed just how closely carbon dioxide and temperature track. At the far right of the graph is us. All of human civilization has existed in the last 10,000 years, an incredibly stable period. We've never known the temperature to vary by more than 1 degree. Until now. We are now entering uncharted territory. By 1992, the evidence for human-made global warming was so strong and the implications so concerning that the Intergovernmental Panel on Climate Change was established to review all of the science on global warming. Since 1992, the IPCC has conducted 5 such reviews. The most recent was published in 2014. It was the result of a collaboration by over 800 scientists representing 80 countries who reviewed over 30,000 scientific papers. It is one of the most comprehensive science reviews ever conducted. If those papers were compiled into one stack, the papers reviewed by these scientists would be at least 900 metres tall, taller than the tallest building in the world. The conclusion of the latest IPCC report is that the existence of global warming is unequivocal. It is 95 to 99% likely that greenhouse gas emissions from human activities are the main cause of this warming. And if we keep producing greenhouse gases at the same rate as we have, the globe will warm between 3 and 6 degrees on average by the end of this century. But what does all this really mean? More hot days means heat waves that kill crops, livestock, and people. The heat waves melt ice, decreasing water for drinking and farming, destroying animal habitats, and increasing sea levels. Warmer air also holds more water, so it takes longer to rain, creating drought. The combination of heat waves and drought leads to increased fires. Then when it does rain, there is more water to fall, resulting in floods. For all the heat energy that has gone into our atmosphere, 25 times as much has gone into our oceans, bleaching coral and affecting other marine species. The heat in the ocean also creates the energy for intense and longer-lasting storms, like Hurricane Katrina, Cyclone Yasi, and Typhoon Haiyan. All of these things impact the foundations of our society: our water, our food, our health, even our homes and the essential infrastructure of our cities. With only 1 degree of warming, we're already seeing an increase in frequency and severity of all these disasters. Heat waves are increasing across the globe, including in places that we don't expect them. In the cold climate of Russia, many people thought global warming would be quite pleasant. But in 2010, a heat wave struck. Temperatures that rarely go above 30 went as high as 42 degrees. Forests burst into flames, crops were decimated, and over 56,000 people died from the effects of heat or smoke. Russia declared a national emergency. In Queensland in January of 2014, heat killed 45,000 flying foxes in one day alone. Whilst the species as a whole can recover from events like this every now and then, if mass die-offs become frequent, flying foxes could become extinct. Fruit bats are the main pollinators of the eucalyptus forests. Without the eucalyptus forests, there's no habitat for many other species. Whilst Australia has always been a land of drought, in Queensland at the moment, 86% of the state is drought declared. It is the most widespread drought on record. This drought is so far only a few years old, but farmers are already saying it is worse than the previous 8-year drought, which was at the time declared Queensland's worst drought ever. Farmers are having to sell thousands of cattle, or if they can't sell them, kill them. Families that have been on the land for generations risk losing their farms. Charities are reporting children on Australian farms with signs of malnutrition because their families can no longer afford things most Australians take for granted. Drought usually comes during the El Niño period in Australia, but this drought is already the worst Queensland has experienced, and El Niño has yet to arrive. In Australia, we have not yet experienced the worst impacts of drought. In countries like Somalia, drought means famine. In 2011, the worst drought in 60 years affected over 10 million people. Families were forced to abandon their dying farms and walk all the way to Kenya to reach refugee camps where there was food and water. Aid workers told stories of mothers with children that were too starved to continue walking. carrying the child would have slowed them down and risked the lives of their other children. So they were forced to leave their starving child by the side of the road, alone.
What they are seeing is scary. What they are seeing is not what they're used to at all, and that's terrifying.
Lack of rain and hotter conditions are leading to more fires that are more intense, lasting longer and happening in places we have never seen them before. Firefighters in countries like the United States and Australia are questioning whether there are limits to what they can fight. After the Black Saturday bushfires, the most devastating that Australia has ever experienced, Peter Marshall, the National Secretary of the Australian Firefighters Union, penned an open letter to the Australian Government on behalf of 13,000 firefighters. He asked that Australia follow scientists' advice. Without a massive turnaround in policies, he said, aside from the tragic loss of life and property, we will be asking firefighters to put themselves at an unacceptable risk. Increasingly, severe droughts are being broken by record floods. Texas has been crippled by drought since 2010, but in May 2015, floods and twisters descended on Texas. In one area, up to 1,000 homes were washed away. Farmers who had prayed for rain, after first breathing a sigh of relief, soon realised it had washed away crops and nutrient-rich topsoil. But it's not just farmland that is affected by floods. The homes and neighbourhoods we've worked so hard to build can be swept away in an instant.
Oh my God!
But what really keeps climate scientists awake at night are feedback loops. For example, white ice reflects sunlight, cooling the planet. As ice melts due to climate change, that cooling no longer occurs, increasing the warming and melting more ice, which creates more warming, melting more ice, and so on. Over 90% of glaciers around the world are already melting. Mount Kilimanjaro has lost 80% of its snow over the past century. Glacier National Park in Montana will soon have to change its name. Of 150 glaciers that were present in 1910, there are now just 30. The Himalayas, the sole source of drinking water to 1.5 billion people, are forecast to disappear by the end of this century. Burning forests also create feedback loops. Healthy forests absorb carbon dioxide from our atmosphere, helping to slow global warming. When forests burn, they release all that carbon dioxide they've absorbed, increasing global warming, creating conditions for more fires to release more carbon dioxide, and so on. And then there's the permafrost. Permafrost is permanently frozen ground in the Arctic Circle. Frozen in the permafrost is methane, a greenhouse gas that is 20 times more potent than carbon dioxide. Scientists estimate the world's permafrost holds the equivalent of more than double the amount of greenhouse gas that humans have already released into our atmosphere. If the permafrost melts, that methane will be released and could increase global warming dramatically. Scientists fear we could push global warming to a tipping point. A point where even if we stopped producing any greenhouse gases, these feedback loops could reinforce one another, leading to runaway global warming. Warming that we are powerless to stop. Despite decades of research, scientists don't really know when such a tipping point could occur. Politicians have set a target of 2 degrees Celsius as the maximum safe level for global warming. To avoid reaching 2 degrees, the United Nations International Panel on Climate Change has calculated we need to peak our greenhouse gas emissions by 2015 and then decrease them to zero emissions by 2050. If we peak later than 2015, we may have less time to get to zero. Fortunately, the world is responding. Many countries around the world have set ambitious targets for clean energy by 2020 and are on track to meet them. Iceland, Norway, Paraguay and Uruguay already have 100% renewable energy, and Costa Rica and Brazil are not far behind. In the United States, solar power has increased by 77% in just 4 years, adding 140,000 new jobs in 2013 alone. China has more solar panels installed than the whole of the rest of the world combined, and is installing wind turbines at the rate of 1 every hour. In 2015, China installed 15 gigawatts of solar panels. This year, they will install 20 gigawatts. Australia's entire energy system is around 22 gigawatts. China will install almost enough solar energy to power the whole of Australia in just 1 year. By 2022, India will install enough solar energy to power Australia 4 times over. And Bangladesh has announced its ambition to be the first solar nation. They plan to have solar panels on every home by 2021. To achieve this, they are installing a new solar home every 90 seconds. It is cheaper for them to install solar panels than to build new coal-fired power stations, plus the poles and wires to transport that energy to people's homes. And it employs more people. In general, clean energy provides double the number of jobs per dollar invested than coal-fired energy. In much of the world, wind turbines and solar panels are already cheaper to build than a coal-fired power plant. Deutsche Bank predicts that by 2017, they will be as cheap, if not cheaper, than existing power in up to 80% of the world. In 2015, Tesla announced the Powerwall, and since then, battery prices have plummeted. All of this and more has led some to declare the age of fossil fuels to be over. And it's not just energy. Imagine a world where we invest in public transport, as Curitiba in Brazil has done, making travel easier for everyone and resulting in the lowest air pollution in the country, even though it is a centre for manufacturing. Imagine a world where cities are tearing down freeways to replace them with parks, as Portland, Oregon did in the 1970s. Their parks have decreased crime and congestion and made for a thriving and livable city. Imagine a world where urban forests are being planted, as Adelaide is doing, and rural farms like this one in Australia, where they have covered 1/5 of their land in trees. Imagine rooftop farms like this one in New York. Imagine a world where our homes, our workplaces, and even our cities are a source of food, water, and energy. Changing the way we use energy, run our farms, design our cities and our homes can not only stop global warming, it would make our cities healthier, safer, vibrant, and happier. But we are not moving fast enough. Despite all of this, we are still changing the climate rapidly. If we continue to act as we have, we would warm the globe by 2 degrees by 2035. Even recent commitments would still see us reach 2 degrees by the end of this century. 2 degrees was a target set by politicians because it was thought achievable, but many scientists warn it is dangerously high. 2 degrees is more than twice the increase we've already experienced, which is already causing disturbing impacts. 2 degrees has been called a suicide pact by African nations and will condemn Pacific Islands to oblivion. Leading scientists have predicted that if we exceed even 1.5 degrees, there's a high risk the permafrost will hit its tipping point and that we may lose 90% of all coral reefs in the world. But these effects might kick in sooner. Scientists can't be sure. There is no guaranteed safe amount of global warming. We don't know for sure what the consequences of delaying action will be, but we can be certain that we don't want to find out. The good news is the world hasn't really started trying to fix the problem. World governments have pledged to keep global warming below 2 degrees Celsius, but their policies and actions will see us shoot past that. New coal, oil and gas projects are still being approved. Governments give tax breaks and subsidies to fossil fuel companies, worth almost $500 billion every year. What could we achieve if that same money was spent fixing climate change? In Australia, we're even tearing down the few climate-friendly policies we had, and our emissions are increasing. What if we put the same effort that was put into winning World War II into fixing climate change? What if we put the same effort that was put into getting humans on the moon? Humans can do incredible things when we choose to. The question is, what will we choose?